Welcome to the lecture 2 of the topic SHM. So, what is the full form of SHM? SHM means simple harmonic motion. So, we will be dealing with today the first topic of the subject physics, that is SHM, and in this we will know about the definition of SHM, about the characteristics, and we will see some examples also. Okay, now the first thing what we will learn is the definition of SHM. Okay, so let's see. It says that SHM full form is simple harmonic motion. So SHM is defined as the periodic motion. Periodic motion means which is occurring in regular interval of time. Like in every day in the morning, what you do? You brush your teeth, right? So that means you are doing every day. That means you are repeating the process. That means this periodic motion means regular intervals of time it occurs. That means it repeats at a body and in which the force is always directed towards mean position and its magnitude is proportional to its displacement from mean position. Now what this statement mean? See, this is we know that SHMs is of two types, that is linear SHM and angular SHM. So we need to know this sentence, then only we can understand these types also. Okay, so let's bring a picture. So this is a picture of a pendulum. So this equilibrium position is a mean position. That means when you exert a force here in the ball, it moves either this side or either this side. But after some point of time, what happens? It will again move back to its equilibrium position. So when it moves like this, in this position, that means this position, this is the mean position. That is being only stated that the force is always directed towards mean position. That means the force will be directed always this side. That means opposite of where it has been exerted. Okay, so you understood this till much, right? This whole concept, this is the basic concept. So it says that magnitude is proportional to its displacement from mean position. So here this portion, what happens, the displacement is the amplitude. Now there are two types. One is linear SHM, another is angular SHM. So let's move on. So now what we will do the definition of types of SHM. So the first is the linear SHM. So you have seen the pendulum, right? So what it's doing? It's going to and fro. But whenever it is linear SHM, that means when you are walking in a straight line and you are moving forward at a certain distance and again coming back. And now you are moving at the backward and again you are going to the position because there is no change in your angle. You are going in a straight line. So the main concept for this linear SHM is that you need to be in a straight line. So when a particle moves to and fro about a fixed point, which is known as equilibrium position or mean position, along with a straight line, that's why I have underlined this term, that is straight line, then its motion is called linear simple harmonic motion. That means linear SHM. So for example of this type of SHM, it is spring mass system. Okay, the next is the angular SHM. For this we require this picture. See what happens here. This is the change which is being occurring, that means this theta. So the basic difference between linear SHM and angular SHM is that in angular SHM the theta changes. So when a system oscillates angular along with respect to a fixed axis, so this is the axis and it's moving like this, right? So this is the theta which is being changed. So this is called angular simple harmonic motion, and for example we will say this is a pendulum is the example for angular SHM. So now we will move on. We have done the definition of the SHM. We have done the example of the SHM with its types. Now we will move on to the characteristics of the SHM. So the characteristics are, SHM is a type of oscillatory motion. That means what is happening? You can see a ball is moving in direction like this, another in this direction. That means it is oscillating. You have seen that grandfather's clock, right? It moves to and fro. You can see that all those are oscillatory motion. Okay, this SHM is a particular case of periodic motion. The third point is the body must be elastic. See, you have seen rubber band. So when you stretch the rubber band and release it, what happens? It comes back to its original shape. So it must be elastic, then only SHM can occur, because it will go back to its restoring position, or it will be going back to its deformation after deformation. Okay, so the body must be elastic. It must consist ample amount restoring force to pull it back after deformation. Okay, now see, the ball is moving, so there will be some acceleration. So the acceleration A of the body, that means this ball's acceleration A, is directly proportional to its displacement x and is always towards the equilibrium position. See, the basic concept is what? The displacement is negative. Why negative? I am telling. See, the acceleration is in the direction, that means the displacement is having, it is negative because the force is exerted to the mean position. That why is it is negative. That means the acceleration is always directed towards the mean position. Acceleration is always directed toward the mean position, so its sign is negative, as well as the force which is being exerted is also towards the mean position. Okay, so I hope you understood the lecture of today, the second lecture of SHM. So till then, be happy and have a great day. See you all in the next lecture.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.